Hi, this is Barry Walsh, your COVID-19 Math 10 online teacher. Today's lesson, Systems of Linear Equations, the Elimination Method. The elimination method does not use graphs. If you recall, sometimes the intersection point on graph paper is difficult to read because it does not fall on one of the little corners of the squares on the graph paper. So we have to guess at where the intersection point is. Now, the elimination method is an algebra method, gives you the exact answer every time. I broke this down into 3 levels. Level 1, not many steps involved. Level 2, 1 more step. And level 3, 2 more steps. And I really like the elimination method. I think it's great. Saves a lot of work when you start thinking about graphs. Now, the elimination method is also called the addition method. And you'll see why in just a second. Okay, so let's look at question 1. What we do here is we add. That's why it's called the addition method. But by adding, we eliminate one of the variables. And once we eliminate one variable, it's an equation that is easily solved. Okay, so let's add these 2 equations. Remember, there's a 1 here and a 1 here. And if you add 1x and minus 1x, you get 0x. So I'm just going to cross those out and say they cancel each other. So already we've eliminated x. Next, add 3y and negative 2y. That gives us 1y. Bring down the equal sign, and we also add over here 17 plus negative 13 is 4. The coefficient of y is 1. We don't really have to divide here because we know we get the same thing. So y is equal to 4. So far, pretty easy, isn't it? So the next thing we do is we substitute 4 for y in one of the equations. It doesn't matter which equation. We're looking for the intersection point. So it's going to be the same for both. Let's go with number 1. Looks pretty simple. So I copy down the equation 1x plus 3y equals 17. So we're substituting 4 in place of y. So we get 1x plus 3 times 4 equals 17. And now we just work this out to find out what x is, because we already know y. So 1x plus 3 times 4 is 12 equals 17. Bring that down. Now we have a rather simple equation to solve. We do opposite operation, plus 12 minus 12. And on the other side, we subtract 12. Subtract from this side. Subtract from that side. And x equals 5. And if we were to graph those 2 lines, the intersection point would be 5, 4. Now that's a lot less work, isn't it? Sure is. Setting up graph, you know, having graph paper and all that. Okay, so that's level 1. Level 2. Now in the second question, if we add the two equations together, 7x plus 3x gives us 10x. That's not eliminated. That doesn't do us any good. Let's look at the y's. 2y plus 4y is 6y. That's not eliminated. That doesn't do us any good. So what we have to do is look at the two equations and see if we can multiply one of the equations by something, by some number, so that either the x's or the y's cancel out. And in this case, there's no whole number you can multiply by 3 to get 7, but there is a whole number you can multiply by 2 to get 4. And that, of course, is 2. But we have to make it a negative 2 because we want negative 4 and 4 to cancel out, or when you add them to get 0. Okay, let's multiply. We don't have to multiply the second equation by anything, just the first equation. So negative 14x, that's an x, minus 4y equals 14. Negative 2 times negative 7 is 14. Negative 2 times 2 is 4y. Negative 2 times 7x is negative 14x. I'm just double checking so I don't make a careless mistake. Okay. The second equation is just copied down as is. And now, just as we did before, we add. And that's why it's called the addition method. And why is it called the elimination method? Because when we add, in this case, the y's get eliminated. Negative 4y and 4y is 0. Pretty neat, isn't it? Negative 14x plus 3x, that gives us negative 11x. And that is equal to, over here, 14 and negative 3 is positive 11. Now we have a simple multiplication equation to solve. Divide by negative 11 on both sides, and we get 1x, or x, equals negative 1. So our step, once we have the first variable, or the value of the first variable, we substitute. So I'm going to substitute negative 1 for x in one of the equations. Now, is there an equation that looks easier here? No, they both look pretty easy. If there's one with a fraction, I would stay away from that. But they're both pretty simple looking equations, so I'll just go with the top one. 7x plus 7x plus 2y, pardon me, that's a 2, equals negative 7. And what we're doing is we're taking the negative 1, and this time we're putting it in for x. So 7 times negative 1 plus 2y equals negative 7. Does that look okay? We're just taking the negative 1, placing it in for x. 2y stays the same, and everything over here on the right hand side of the equal sign stays the same. 7 times negative 1 is negative 7, plus 2y equals negative 7. Now we have a simple equation with one variable, and you know we can solve that. Do the add subtract part first. Negative 7 plus 7. So 2y equals negative 7 plus 7. What do we get when we add negative 7 plus 7? Of course we get 0, right? So bring down 2y equals 0. Divide both sides by 2. Y is equal to 0. If we were to graph these two equations, what would the intersection point be? It would be negative 1 and 0. And that's it for level 2. Okay, the last one, level 3, number 3. And it's not that level 3 is really difficult, it just involves an extra step from level 2. And if I started with this question, some of you, maybe all of you, would wonder what I was doing, and I think level 1 is a better place to start, because you're going to run into all three types of questions, no matter what book you're working from or whatever your teacher gives you. Okay, so if we add 5 and 3, we get 8x. That doesn't cancel out, does us no good. 4 and 5, we get 9y. That doesn't do us any good. Is there anything, a whole number we can multiply by 3 to get 5? No. Is there a whole number we can multiply by 4 to get 5? If we wanted to work with the y's, we'd have to multiply something by 4 to get 5, and there's no such whole number. So what that means is we have to multiply both equations by something so that either x or y will be eliminated. In this case, it doesn't matter if we work with x or with y because they're both reasonably small numbers. Now let's say for a second this wasn't 5x and it was 35x, and this was 3. Well, I would choose not to work with those two, and I would work with the smaller numbers 4 and 5. But 5 and 3 and 4 and 5, they're both small numbers, so I'm going to work with the x's here. So this is a good way to do it. Look at the number that's on the bottom, 3, and put it up top. Look at the number that's on the top and put that on the bottom. And what we're going to do is multiply the top equation and then the bottom equation. And if we do that, 3 times 5x is 15x, and 5 times 3x is 15x. Well, that isn't going to cancel, but we're really close. One of these has to be a negative. Now, you could make the 5 negative if you wanted to. It doesn't matter. All right, let's multiply. Negative 3 times 5x is negative 15x. Negative 3 times 4y is negative 12y. Negative 3 times negative 2 is 6. That's supposed to be a 6. I need to get a new red marker. This one's getting kind of blunt. All right, 5 times 3x is 15x. 5 times 5y is plus 25y. I'm not going too fast, am I? And then 5 times 17, that's 85, I think. Yes, it is 85. I just double checked in my head. Okay, so again, we add. Now it doesn't matter which level question you're doing, you still have to add, right? That's why it's called the addition method. So if we add negative 15x and 15x, what do we get? We get 0. So the x's are eliminated. Thus, the elimination method. So if we add negative 12y and 25y, we get 13y. And if we add 6 and 85, we get 91. That sound okay? I think that's right. So now we have to divide by 13 the coefficient of y on both sides. 13 divided by 13 is just y. And 91 divided by 13 is 7. Yes, it is. So y equals 7. Substitute, again, it's the same step, substitute 7 for y in one of the original equations. Whoops. Both these equations have small numbers. There's no decimals. There's no fractions. It wouldn't matter which one you take. I'm just going to take the top one. 5x plus 4y equals negative 2. And I'm going to put 7 in here in place of y. So 5x plus 4 times 7 equals negative 2. So I'm just bringing down the negative 2. 5x plus 28 equals negative 2. 4 times 7 is 28. Bring down the equal sign, bring down the negative 2. So now we have to do opposite operation to get rid of this 28. So it's add 28, so we subtract 28. I'm taking the shortcut here, okay? So 5x equals negative 2 minus 28. Remember, the shortcut for opposite operation, if it changes sides, it changes signs. So 28 on the left side minus 28 on the right side. When you add these together, you get negative 30. Bring down the 5x. What's the next step? Divide by 5, right? These cancel. 5 divided by 5 is 1x, or just x, doesn't matter. And answer, negative 30 divided by 5 is negative 6. What is the intersection point? Negative 6 and 7. So if you drew the two lines, this is where they would intersect. In order to graph this particular system of linear equations, you'd have to put it in y equals mx plus b form, and then you'd have to set up your graph. You do your graph, and this one works out to be a nice set of round numbers, but sometimes they don't, as we saw a couple of lessons ago. So I really like the elimination method. I hope you do too. So I have some practice questions for you today on sheet 2, which I just happen to have right here. So once again, how about stopping the video, taking a picture of this with your phone. The answers are here, but they're not in order. And You can do some homework, work on these. Again, you guys need practice. It's so important to practice in math. And if you want to give me a thumbs up on the video, I'd appreciate that. Thanks very much for watching. Have a great day.